Welcome to CIVIL-MECH-MATHS CONCEPTS channel run by me, and today I will be taking up a very good question on number system for CAT, GRE and GMAT Quant, Quantitative Aptitude. And in the first lecture we have seen how to find the remainder when a bigger number is divided by a smaller number, like bigger number is exponential or something, like 10 to the power of 1000, 10 to the power of 100, 10 to the power of 2025, like that. Here, instead of exponential, we will be taking the factorial. When a big factorial number is divided by a prime number greater than the largest number in the factorial, how to find the remainder? If anything less than 91 or a factorial number, then remainder will be 0, because factorial means it is 1 into 2 into 3 up to the number divided by some number in between 1 and p. Then there is no problem, the remainder will be 0. But 91 factorial is divided by 97. 97 is bigger than 91. 97 is greater than 91. Then what happens? How to find the remainder? And 91 factorial is also not a small number where you can do it manually. You cannot do. It will be nearly impossible to do in an examination like CAT, GRE, GMAT, where time is limited to solve a question in seconds or in a minute, whereas 91 factorial itself calculation is not possible. Then what to do? How to solve it? How to find the remainder? We have found the remainder 10 to the power of 2025 when it is divided by a prime like 7. Now here 97 is also a bigger number, 91 factorial is also a very big number. Then what to do? Let us go. Let us try to solve this. In this, not only factorials, we will be discussing about the Wilson theorem and also a new theorem called extended Euclidean algorithm. Extended Euclidean algorithm we will be discussing about. We may not be able to understand fully or discuss fully in this small lecture. We will be concentrating on solving this problem in the next class, next lecture. I will be explaining what is extended Euclidean algorithm in detail. You see the lecture till the end. Try to grasp whatever I tell you in this about extended Euclidean algorithm, if it is new to you, and if you are familiar with this, please refer to the textbooks or other resources and try to understand it. I will clarify and I will make you understand what is extended Euclidean algorithm in the next lecture. Let's move further. Why I have taken this? I want to make you appreciate the importance of the number theorems, number systems, because I have already explained you different types of number systems to you in the last class. And let's extend our discussions on various lectures on different methods of solving different types of problems. If you are unfamiliar, try to understand the theorem. If you are familiar, try to make yourself stronger and stronger to face the examination. Let us move further. What is the question given here? Find the remainder when factorial 91 is divided by 97. Solution. Let us try to bring back our knowledge of when our factorials are involved. What is the theorem? The theorem name is Wilson's theorem. Bring in Wilson's theorem. Here factorial is involved and also prime number is involved. 97 is a prime number. I have already told you to remember prime numbers up to 100, or at least you have an idea. Look at them daily. At least for 10 days if you look at them on a continuous basis, it will be imprinted in your mind. At least you will know 7 is a prime, 17 is a prime, 19 is a prime, 23 is a prime, 97 is a prime. Just like a fun also you can remember. 97 is a prime number. When our primes, factorial 91 is there and 97, a prime is there that attracts Wilson theorem. Let us say mathematics is application of various theorems. Let us apply prime number Wilson theorem. Here what Wilson theorem says? Factorial p minus 1 is equivalent to minus 1 mod p. Here p prime number is 97. This means as per Wilson theorem, factorial 97 minus 1 is equivalent to minus 1 mod 97. That implies 96 factorial is equivalent to minus 1 mod 97. What is the meaning of it? 96 factorial equivalent to minus 1 mod 97 is equivalent to, means 96 factorial plus 1 is divisible by 97. Do you agree? This is what is the meaning. Now, here given is 91 factorial, 96 factorial is not given. Then 96 factorial can be written as 91 factorial into 92 into 93 into 94 into 95 into 96. Do you agree? Because 96 factorial equivalent to minus 1 mod 97 implies, can we write 96 factorial as 91 factorial into 92 into 93 into 94 into 95 into 96? Yes, we can write. Replace 96 factorial with this. What happens? 91 factorial into 92 into 93 into 94 into 95 into 96 equivalent minus 1 mod 97. Can we write like this? Exactly. But what is 96? 96 equivalent to minus 1 mod 97. Can we write like this? 96 plus 1 is 97, divisible by 97. Then 95 equivalent to mod minus 1 mod minus 2, sorry, minus 2 mod 97. Can we write like this? Because 95 plus 2 is 97. Then can we write 94 equivalent minus 3 mod 97? Similarly, can we write 93 equivalent minus 4 mod 97? Can we write 92 equivalent minus 5 mod 97? Can we use all these and replace in this? All these things can we replace in 92, 93, 94, 95, 96. Let us see. Then the original equation becomes 91 factorial into, what is 96, 92, 92 is minus 5 into, what is 93, 93 is minus 4 into 94 is minus 3. Please try to understand the process. I am going slow. In the examination you can write fast. Minus 5 into minus 4 into minus 3 into minus 2 into minus 1 equivalent to, all are mod 97 only. Minus 1 mod 97. Do you agree? I have only replaced 92, 93, 94, 95, 96 with these mod values. Then 5 into 4 is 20, 20 into 3 is 60, 60 to 60 into 2 120, minus minus plus minus minus plus minus. Now can we write like this? 91 factorial into minus 120 equivalent to, what is that? Minus 1 mod 97. You just see, it is a rearrangement of everything. Mathematics is a beautiful science. Just see, by rearranging how we are able to do it. Now, let us concentrate on this value. What is minus 120? How to write minus 120 in mod 97 form? Can we write minus 120 equivalent to minus 23 mod 97? Because minus 120 plus 23 is equal to 97. This much you will be knowing from your basic arithmetics, from your elementary arithmetics knowledge. 97 is minus 120 plus 23. Because mod 97 and minus 120 we have to relate. Then this minus 120 plus 23 is equal to 97. When minus 120 is divided by 97, there is a minus 23 is the remainder. Do you agree? Now, this step. That means minus 120, can I write it as minus 23? Yes. You can correlate between this and this. Now, the main equation becomes 91 factorial into minus 23 equivalent to minus 1 mod 97, it will be same. Because minus 23 mod 97, everything related to minus 120. This minus 23 I have put in place of minus 120. This mod minus 1 mod 97 I have not disturbed. Right hand side I have not touched. Okay. right hand side is not changed in the main equation. Now, these steps I have already explained you in the first lecture. Please refer to them. If you have any doubts, please put it in the comments. I will reply to you. I will clarify to you. Then, let us multiply both sides by -1. Multiply both sides by -1. What happens? 91 factorial into 23 equivalent to it. -23 becomes +23, -1 becomes +1 on right hand side. Mod 97. This is what we have got ultimately. This is what we have to solve 91 when divided by 97. 91 factorial when multiplied by 23 and divided by 97. Please try to understand what is the meaning of it. 91 factorial into 23 when divided by 97, it gives a remainder of 1. But we are not interested in 91 factorial 23. We are interested in 91 factorial only. That means we have to take steps to eliminate this 23. In this, it is the what we call it as modular inverse of here something into something equivalent to something mod something. Then we want like A into B modulo C equivalent to C mod D. We want to eliminate B. We want only answer for A. Then this B will be modular inverse. We have to find the modular inverse of B so that we can eliminate B. How B can be eliminated? When x is there, x can be eliminated only when multiplied by 1 by x. B can be eliminated only by multiplying with 1 by B. Because it is not a direct mathematics or direct arithmetics, direct algebra, it's a modular arithmetic. We have to replace this as with some modulo inverse of B. We have to find modular inverse of 23 to keep only 91 factorial. What is that modular inverse of a number? Here we have got another definition called as modular inverse of a number. This can be found out from extended Euclidean algorithm. Extended Euclidean algorithm. We have to find out modular inverse. What is 23 to the power of -1? From Euclidean, extended Euclidean algorithm, 23 power of -1 equivalent to 38 mod 97. Because in terms of mod 97 we want. We don't want mod 1, mod 2, mod 3 because our main question is with respect to mod 97. Using the extended Euclidean algorithm, 23 to the power of minus 1 is equivalent to 38 mod 97. Hence, when you apply this in this, then our answer 91 factorial into 23 equivalent 1 mod 97 becomes because 23 inverse of 23 is 38 mod 97. How it has come? That is the crux of the question, which I will be explaining in the next class. I will be extending this lecture for another round of next class lecture, so that I will make you understand the extended Euclidean algorithm. Then this becomes 91 factorial equivalent to, instead of 1 we will write 38 mod 97. Why this example I have given? We can never expect that only 2-step, 3-step questions will be asked. This is not a tougher, it is a very tough question, but it is not a physically involved, more steps are involved in this. In this, logic is involved. In this, understanding of the Wilson theorem is involved. Along with the Wilson theorem, we have to understand how modular arithmetic goes on and how to use the modular arithmetic to find a solution to a problem given in the examination. And this extended Euclidean algorithm, I thought, let me tell you a brief about it, so that if this type of question comes in the examination, you will not be unfamiliar with it. Familiarity is more important. Now, I want to conclude today's lecture. Answer is 38. Answer is 38. How this Euclidean algorithm, extended Euclidean algorithm is applied, I will let you know in the next lecture. Till that time, please read some classical books on modular arithmetic and try to understand. Best of luck to you in your examinations, and for the mathematics enthusiasts also, best of luck in understanding these theorems, and thank you for viewing my lecture. Thank you for listening to me. If there is a value addition to your knowledge because of this lecture, please share my channel and also videos, and subscribe to my channel CIVIL-MECH-MATHS concepts. This type of questions are not only for CAT, GRE and GMAT, they can be useful even for GATE examination, where a tougher general paper will be there. Actually quantitative analysis it is not called as, it is a aptitude. In the aptitude test for engineers also, this type of questions may be asked. Please try to understand the concept of extended Euclidean algorithm and also Wilson theory. They are the very, very important theorems in number theory. Fermat little theorem also I have explained in the previous class. Best of luck. Thank you.